Good morning, everyone. This is one more session with respect to IPC mechanisms. So before starting with the today's session, if my voice is clear, able to see the screen properly, please type 1 in the chat box. If my voice is clear, able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If able to recollect, what is the discussion happened in the last session? In the last session, we are trying to understand some more properties of pipe. After that, we started with the discussion of named pipe is also called as FIFO. Okay. Yesterday's session, we are trying to understand some more properties about the pipe. After that, we started thinking about one more IPC mechanism that is called named pipe. I'll ask some questions, try to answer it if possible. Suppose if suppose this is a right end and this is the read end. Now can you tell me, when right end is closed, if you're trying to read from the read end, then what is the read will return? If right end is closed, if you're trying to read from the read end of the pipe, then read will return 0, means end of file. Indication that communication is going to be stopped. Will you agree? Okay. If I do reverse, suppose there is a pipe, read end is closed, you are trying to write from the right end. So the process who is going to write from the right end where read ends are closed, then the SIG pipe signal is generated. What is the default action? What is the default action? The process gets terminated. Can we handle it? Can we handle this signal? Answer is yes, we can handle, and we can give the control again back to the main. Now tell me, when we open a file, when we create a pipe using the pipe system call, both read end as well as write end, sometimes it will act as a blocking. When the pipe is full, write will block. When the pipe is empty, read will block. So if you don't want to block those ends, then you need to create a pipe using pipe 2 system call. And you need to put what is it? O underscore non-block. So in this case, what happens? When the pipe is empty, if any process is trying to read, read will fail. If the pipe is full, if any process is still writing, write will fail. It will not block. Now tell me, if you don't want to unblock both ends, only right end only you need to unblock, then what is the process? If you don't want to unblock both ends, only right end is only you need to unblock, then what is the process? Can you see we need to use FCNTL function? That is also discussion happened in the last session. After that, tell me, what is the disadvantage of pipe? What is the disadvantage of the pipe? only related processes can communicate. Unrelated cannot communicate. So to overcome this, one more IPC mechanism came. What is it? To overcome this, one more IPC mechanism yesterday we started, that is called named pipe, that is also called as a FIFO. So what are the commands to create a FIFO? What are the commands to create a FIFO? MK FIFO, MK node. These are commands. As well as what are the functions? MK FIFO, MK node. So here the command name, function name is same. Using the MK FIFO or using the MK node, you can create a FIFO file. Function also you can create a FIFO file. So when you create a FIFO, where the file is created? When you create a FIFO file, pipe file, where the file is created? In a hard disk. But in this file, anything is going to be stored like a regular file. In this file, anything is going to be stored like a regular file? Answer is no. But why the file name? Why the file name? Just for opening purpose. Just for opening purpose. So there is no data is going to be stored permanently, just for reference purpose, just for opening purpose, but there is no data is going to be stored permanently. There is no data is going to be stored permanently into the file. Yesterday we started thinking about this, right? Yesterday we are trying to implement one process, W1 process, another process called R1 process or read process. This process job is to scan the data from the keyboard, put it into the FIFO. This process job is to read from the FIFO and print it on the screen. Now here only we finish the discussion. So this program detailed today we need to talk. So many important properties today we need to talk about. So this is the program. This process is to scan the data. Observe the line number 18, 16 and 17. The job of this process is to scan the data from the user and put it into the FIFO. Line number 16, MK FIFO. Now with this what we are trying to do? Using this function, we are creating FIFO file. Using this function, we are creating the FIFO file. Okay. If file is already there, already present, this function will fail. Again, MK FIFO, I'm creating the FIFO file. One of the important property of this function is, if file is already present, this function will fail. Now tell me, am I checking the failure condition? I'm coming out of the program here. Observe the line number 8 and all other things. Am I checking the failure condition? I'm coming out of the program. No. As I told you, we can create a FIFO file using create FIFO using command also, then this function call not required. Again, if you might have created a FIFO using the command, then this function call is not required. Read this point. Using this function, we are creating the FIFO file. If file is already present, this function will fail. We can create a FIFO using the command also. Then this function call is not required. Line number 6 is not required. Will you agree? Line number 6 is not required. If this point is clear, type C in the chat box. If this point is clear, type C in the chat box. So can I say, in our process calling the MKFIFO, is not a mandatory. It is simply optional. In our process calling the MKFIFO is not a mandatory. It is an optional. Okay, next. What is the line number 11 we are doing? In line number 11, what we are doing? We are opening the FIFO file. Here we are opening FIFO file for writing purpose. We are opening the FIFO file for writing purpose. Yes or no? One important point I need to tell you. Open will block if any process is not opened. Open will block if any process is not opened for reading. Now I'll tell you one important point here. Observe the line number 10, what I'm trying to do. Observe the line number 10, what I'm trying to do. I'm trying to write single lines there, dot, 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 dot. Observe the line number 14. Observe the line number 15 now. Can I say there also I'm trying to do dot, 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 dot. Some lines I'm printing, dots I'm printing. Now let me compile the code. Let me run the code. Now, first line is printed, but second line is not printed. Now, first line is printed, but second line is not printed. What is the meaning? Can you tell me? Observe. This line is printed. Line number 10 is printed, but line number 15 is not printed. Line number 10 is printed, but line number 15 is not printed. Can I say which function is blocking the process now? Can you tell me which line is blocking the process now? Which line is blocking the process now? Now open is behaving as a blocking function. Why? Why? Because this process is trying to write the data into the FIFO. It is trying to open for writing purpose. Can I say there is no reading process is present, no reader is there? Until and unless reader comes, until and unless read end is opened, this will behave as a blocking function only. Until and unless read end is opened, this will behave as a blocking function only. And vice versa also. What is the meaning of vice versa? If any process came for reading first, there is no writing process is available, right end is not opened, then also it will block. Then also it will block. Getting the point? Getting the point? So imagine the reading process came first. The process is trying to open for reading purpose. but unfortunately there is no writing process is available at that moment, then open will block there. What is the condition here in this IPC? Can you guess? Can you tell me? With this, can you conclude what is the condition? Can I say, if you want to do the transactions using this FIFO, both reading process and writing process should be alive. Again, if you want to do transactions using the FIFO, will you agree both reading process and writing process both should be alive? If this line number 11 is clear, type C in the chat box. The property of line number 11 is clear. Line number 11, this process is trying to open for writing purpose, but at that moment there is no process is opened for reading purpose. So then open will block, and vice versa also. Suppose reading process came. I don't know, yesterday you have observed or not, there is a reading process, /RD. Now observe, when reading process trying to open for reading purpose, when reading process is trying to open for reading purpose, can I say open is unblocked there? Can I say open is unblocked there? Now here scanf is waiting, here read is waiting. In that scanf is waiting for the user input. In this reading waiting for the data from the FIFO. Now if I type the data, observe, receiver received hello world, receiver received hello world. Two are unrelated processes. There is no relation between those two processes. If line number 11 is clear, type 11 in the chat box so that we'll move to the next. What happening in the next we'll discuss. If line number 11 is clear, type 11 in the chat box. Still any doubt about that? Let me know. Okay. Now you tell me. Now after that, what we are trying to do? We are scanning the data. We are writing the data into the strlen plus 1. What is the meaning? What is the meaning of strlen plus 1? What is the meaning of strlen plus 1? Can I say we are putting /0 also into that? What is the meaning of strlen plus 1? Will you agree we are putting a /0 into that? Please respond it. Already these two programs I shared it. Okay. Next, F1 is asking one question. Sir, if there are three processes to a writing process, one is reading process, then open becomes block any one of the writing. See, one of the student is asking one interesting question. There are two writing processes. Suppose this is one writing process. / let me compile this code. -O W1 W2. Can I say two writing processes are there now? I created two writing processes. /W1. Just a minute. /W1. I'll open one more terminal. So cd Linux _89 FM IPC FIFO /W2. Now tell me B8 F1 two writing processes are blocked in the W1. In the W1, open is blocked. In a W2 is also open is blocked. In W1, open is blocked. In W2 is also open is blocked. Why? Because there is no reading process available at that moment. Why? Because there is no reading process is available at that moment. Now suppose reading process came. This is the reading process. Suppose this reading process came. Now observe what happens. Suppose reading process came. Can I say in both open is unblocked because readend is opened now? In both open is unblocked. In both open is unblocked. I hope you understood this. If I write hi here, how can I say? Can I say here hi is received? Now if I type bye here, that bye will not be there. Why? Because there is no reading process. Why? Because there is no reading process. Now what I will do is I will modify this program. After that, write use peer. Write system call. W1 W2 dot slash W1 dot slash W2. Both W1 process and W2 process is for what? W1 and W2 is waiting for readend to open, right? W1 and W2 is waiting for readend to open. B8 F1 will accept this. W1 and W2 is open for open block. Open is blocking because it is waiting for readend. Now readend process came. Both are unblocked. Now if I type here hello, write is file exist it given. Now here hi. Now here write is not showing anything. P error is not displaying anything. Leave it about that. We'll see that. Yeah, I created a separate executable files W1 W2 dot slash W1 dot slash RD. If I type it here, file exist, received it. Okay, let's see what is the thing. So this is what happens. So both ends will be blocked then. Now let's move to the reading process. VI 27 3 dots. Can I say the job of this process is read the data from the FIFO and put it into the screen. Now tell me this is a mandatory or optional? Can you tell me this is a mandatory or optional? Will you agree those are optional? If you want to create a FIFO using the command, that is enough. Again, if this process comes first, reading process, there is no writing process. Can I say open will block? Reading process, then open will block. I'm reading and I'm printing it. Reading and printing it. Now let's see. So this program is for simplex communication. In this program, what they're trying to do is, there are two processes. One process is opened for writing purpose. Another process is opened for reading purpose. And this process just, and this process enter the data, scan it, write it. This is a while one, do while one loop. And here, read and print. Can I say this process is keep on writing the data into the pipe. This process is reading the data from the pipe. One process is writing the data from the pipe. Another process is reading the data from the pipe. So can I say the data is transferring from one side to another side? Can I say this is a simplex communication? Here, in this example, they are writing a string data. In this example, they are writing the string data, but you can write any type of data. Like in this example, you are writing the string data, but you can write any type of data. So this process is trying to write, this process is trying to read. So this is a simplex. The data is in only in one direction. This is a simplex, like this. This process is writing, process 1 is writing, process 2 is reading. Simplex communication. Process 1 is writing, process 2 is reading. It is a simplex communication. Next, half duplex communication. Next, observe half duplex communication. In a half duplex communication, observe half duplex communication. Observe this is one process. It is opened this for reading purpose, read write, read write. Now one thing I need to tell you, if you open for read write, this open will never blocks. Again, when you open for read write, open will never blocks. Why? Because both ends you itself is opened it. Again, when you open a FIFO file, even though you don't want to read it, if you open reading read write, so then what happens is open will never block. So now can you tell me, FDR means reading purpose, FDW means writing purpose. Now observe, first it is writing, then it is reading. First it is reading, then it is writing. Left hand side process, first it is writing into the FDW, reading from FDR. Again, left hand side process, first it is left hand side process, first it is reading from writing into FDW. First it is writing into FDW, reading from FDR. Second is reading from FDR, writing into FDW. All of you are observing this. And that is in a while one loop. That is in a while one loop. Now observe here, that is in a while one loop. The behavior is like this. Process 1, scanning the data from the keyboard, writing into the FIFO, reading from the FIFO, printing on the screen. Process 1, scanning, after scanning, write, after write, read, after read, print. Now my question is it writing and reading from the same FIFO or different FIFOs? My question is it writing and reading from the same FIFO or different FIFOs? Different FIFOs. Why? If it is doing on the same, there is a chance of loopback. . 。   . 。  . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . 。 . . 。 . . 。 . . . . . If it is the same, will you agree? Writing into first FIFO, reading from the first FIFO, can I say writing into first FIFO, reading from the first FIFO, can I say there is a chance of loop back? Again, try to observe here. Try to observe here. In this process, first scanning, next writing, next reading, next printing. While one. Is it clear? But whereas, can you tell me here first what happening? Can you tell me here first what happening? Reading. Next. After reading, it is printing. Next. After printing. Not writing, scanning. After scanning, then writing. Now this side. First read, next print, next scanf, next write. This is in a while one. Now can I say here scanf is a blocking function, read is a blocking function. Here read is a blocking function, here scanf is a blocking function. All of you try to understand this very carefully and let me know. In the left hand side, first I am scanning from the keyboard, writing into the FIFO. After writing into the FIFO, reading from the FIFO. After reading from the FIFO, second FIFO, I am printing on the screen. This process is a continuous. This process I am doing in a continuous. Whereas right hand side, first I am reading from right hand side. Can you tell me first I am reading from first FIFO or second FIFO? Right hand side, first I am reading from first FIFO or reading process 2 is reading from the first FIFO or second FIFO? Can I say first FIFO? After reading from the first FIFO, what the process 2 is doing? After reading from the first FIFO, what the process 2 is doing? Is printing on the screen, correct? After printing on the screen, what it is doing? After printing on the screen, scanf, waiting from the user input. Once a user supplies the input, then what is the next step it is doing? Process 2. Once user supplies the input, what is the next step it is doing? Can I say it is writing? Next step it is writing into. Next step it is writing into first FIFO or second FIFO? Second FIFO. Okay. Now try to understand, this is called as a half duplex communication. Why it is called as a half duplex communication? Try to understand. Now this process 1 cannot read from the FIFO, second FIFO until and unless it writes from the into the first FIFO. Process 1 cannot read from the second FIFO until and unless it writes into the first FIFO. Because this scanf is a blocking function. It will block until user supplies the input. Will you agree? Again, process 1 cannot read from the second FIFO until and unless it writes something into the first FIFO? Please try to answer it. Yes or no? Process 1 cannot read from the second FIFO until and unless it writes into the first FIFO. Now tell me, process 2 cannot write into the second FIFO until and unless if any data received from the first FIFO. Now tell me, in a process 2, it cannot write into the second FIFO until and unless it read from the first FIFO. So can I say at a time only one thing can happen? So this is called as a half duplex communication. Both can communicate. Both processes can communicate, but at a time cannot be. One FIFO is used at a time. Yes. Can I say process 1 cannot read until and unless writes into the FIFO, first FIFO? Similarly, process 2 cannot write until and unless read from the first FIFO. So that's why it is called as half duplex communication. If you understood this, type 2 in the chat box. Now can you tell me, process 1 is writing the data into the first FIFO first or reading the data from the second FIFO first? Process 1 writing the data into the first FIFO or reading the data from the second FIFO first? What first it is doing? Writing the data into the first FIFO. After that only it is reading. After that only it is reading. What about the process 2? First what it is doing? What about the process 2? First what it is doing? What about the process 2? First what it is doing? Can I say it is reading from the first FIFO, then it will write it into the second FIFO. Then only it is eligible to write the data into the second FIFO. Process 2, it is reading from the first FIFO, then only it is eligible to write the data into the second FIFO. Can I say this is called half duplex communication? Next, try to understand, that is full duplex communication. In this full duplex communication, a small change, parent in a while one, here parent and child, parent in a while one, child in a while one, here child in a while one, parent in a while one. In this parent while one, scanf and write. In a parent while one, scan write. In a child while one, read print. In a parent while one, scanf write. In a child while one, read print. Here in a child while one, can you guess? In a child while one, read print. In a parent while one, scanf write. Now here 4 processes are present or 2 processes are present here. 4 processes. In a left hand side, parent and child. In a right hand side, parent and child. Now can you tell me, in a left hand side, parent job is what? In a left hand side, parent job is what? In left hand side, parent job is what? Scan and write. Write into which FIFO? First FIFO or second FIFO? Left hand side, parent job is scan and write. Write into first FIFO. In the left hand side, what is a child job? In the left hand side, what is a child job? In the left hand side, what is a child job? Read and print. Read from where? First FIFO or second FIFO? Read and print. Read from where? Read from where? First FIFO or second FIFO? Can I say second FIFO? Can I say second FIFO? Now can you tell me, here parent need to open the first FIFO for which purpose? Parent need to open the first FIFO for which purpose? Writing purpose. And child need to open this FIFO for what purpose? Child need to open this FIFO for what purpose? Reading purpose. Now here child 2 need to open this for first FIFO for child 2 need to open the first FIFO for reading purpose, and second FIFO for parent 2 need to open the second FIFO for parent 2 need to open the second FIFO for writing purpose. Is that point is clear? Is that point is clear? So here full duplex communication is going on. Here full duplex communication is going on. Now we need to understand one situation called deadlock situation. Now we need to understand one situation called deadlock situation. If this is clear, type C in the chat box. Before entering into the deadlock situation, if full duplex communication is clear, type C in the chat box. But full duplex communication is going on between two processes or four processes here. Can you tell me? Here full duplex we are achieving in between 2 or 4. Can I say 4? In one terminal parent and child, in another terminal parent and child. Let's understand what is a deadlock situation. Now next discussion is what is a deadlock situation. Next discussion is what is a deadlock situation. Suppose there are two FIFOs are there, F1 and F2. There are two FIFOs are there, F1 and F2. So there is one process in one terminal, there is one process in another terminal. This process job is to write the data into the first FIFO. This process job is to read the data from the first FIFO. This process job is to write the data into the second FIFO and read the data from the second FIFO. All of you copy this diagram. All of you copy this diagram. All of you copy this diagram. After that, type C in the chat box. We are trying to understand what is the meaning of deadlock situation. We are trying to understand what is the meaning of deadlock situation. This is one strange situation. This is one unexpected situation. To understand in this topic what is a deadlock, try to copy this diagram. Try to copy this diagram. Once you copied, type C in the chat box. Copy this diagram. Once you copied, type C in the chat box. Once you copied, type C in the chat box. Okay. Now I'll ask some questions. Try to tell me. P1 process writing the data into F1 or into F2. P1 process is writing the data into F1 or in F2. P1 process writing the data into F1. P2 process is writing the data into F2 or into F1. P2 process is writing the data into F2 or into F1. Now can you tell me, P1 process need to open F1 for writing purpose, F2 for reading purpose? P1 process need to open F1 for writing purpose, F2 for reading purpose. P2 process, F1 for reading purpose, F2 for F2 for P2 process need to open F1 for reading purpose, F2 for, yes, half duplex only, don't worry. No matter it is a half duplex, whatever it is. I'm trying to explain you what is the meaning of deadlock situation. So try to understand this scenario. So P2 process is trying to open for F1 process for reading, F2 process for writing. Is this point is clear? Now can you tell me the statement for open? FD1 is equals to open F1 for what? O underscore WR only. I'm trying to write open system call. And can you tell me FD2 is equals to open F2 for what? O underscore RD only. Any doubt in this? Any doubt in this P1 process open system calls? Any doubt in this P1 process open system calls? P1 process is opening F1 FIFO for writing purpose. As per our diagram, it need to open F1 FIFO for writing purpose, F2 FIFO for reading purpose. BE9 S8, is that statements are clear? F1 FIFO for writing purpose, F2 FIFO for reading purpose. Now can you tell me in this side, in P2, now tell me in P2, if I write FD2 is equals to open FD2 is equals to open F2 for O underscore WR only, and FD1 is equals to open F1 for O underscore RD only. All of you copy this. We'll see what is the problem with this. All of you copy this scenario. What is the problem with this? We'll see. All of you copy this scenario. FD1, it is opening F1 FIFO for writing purpose. FD2, opening F2 FIFO for reading purpose. Whereas in a P2 process, first it is trying to open FD2 for writing purpose, and next it is opening for reading purpose. Once these 4 lines, if you copied, once these 4 lines are copied, type C in the chat box. Now can anybody guess what is the problem in these lines? What happens? Can anybody guess what is the issue with this type of things? Now can I say B8 F1, correct? This will block till, because it is trying to open for writing purpose. There is no read end is opened. Can I say this will block? Now can I say this statement will not execute? All of you are observing. As you know, today only I told you, open system call will block if this process is trying to open for writing purpose. If there is no read end is opened, this will block. Now you tell me here, can I say this will block? Can I say this will block? Why this will block? Can you tell me? Can you tell me in this second process why this open will block? In the first process, why this open will block? In a first process, this open will block. Why? Because another process is not open for reading purpose. Another process is not open for reading purpose. Here, this open will block. Why? Because another process is not open for reading purpose. You may say that, sir, here we written open, but this statement will not execute, but because this is blocked. Now, can I say in P1 process this open is blocking, in P2 process this open is blocking? In P1 process the first open is blocking, in P2 process first open is blocking. Can I say both processes never executes? Both processes never continues its job. So can you tell me P1 process is waiting for which pipe and which end to open? Can you tell me P1 process is waiting for which pipe and which end to open? P1 process is waiting for which pipe and which end to open? Can I say F1 pipe, read end to open? P1 process, this function is blocking because it is trying to open for write. There is no reading process is available. Can I say P1 process is waiting for F1 FIFO to open for reading purpose? Whereas P2 process, can you tell me whereas the P2 process? P2 process is waiting for F2 process to open for reading purpose. P2 process is waiting for F2 process to open for reading purpose. Can I say both processes are waiting for each other to open their ends? So can I say this is a deadlock situation? None of the process will continue its job. Again, P1 process is trying to open F1 FIFO for writing purpose and waiting for somebody else to open reading purpose. And P2 process is opening second FIFO for writing purpose. It's waiting for somebody else to open for reading purpose. Please try to understand this strange scenario. Please try to understand this strange scenario. In P1 process, first open is blocking or second open is blocking? In P1 process, first open is blocking or second open is blocking? In a P1 process, first open is blocking or second open is blocking? In both, first is only blocking, right? Yes, sir. So what is the solution? Solution is very simple. This is a programmatically mistake. This is a programmatically mistake. So solution is very simple. FD1 is equals to open F1 O underscore WR only. FD2 is equals to open F2 O underscore RD only. Now here by mistakenly I am opening F2. So now what you do, FD1 is equals to open F1 for O underscore RD only. FD2 is equals to open F2 O underscore WR only. Copy these 4 lines. Let's see. In these 4 lines, in this situation, deadlock happens or not? Copy these 4 lines. Copy these 4 lines. So here, none of the process gets blocked here. Now observe. Now this is blocked. When this is blocked, when this process starts, can I say both will unblock? Here, this process is trying to open for writing purpose. If any other reading process is there, this open will unblock. So reading process came, it will unblock. Now here also the same thing, no blocking happens here. So one process is opening writing purpose, F1 FIFO. Another process is opening F2 FIFO for writing purpose. So there is a deadlock situation happens. There is a deadlock situation happens. Is that is clear? There is a deadlock situation happens. So you should be very careful in that type of programming when you're writing such program, because open will block if another end is not opened. If this situation is clear, the same thing I hope here also they explained it. The same thing I hope here also explained it. Observe, process X opening F1 FIFO for reading, opening FIFO A for reading, FIFO B for reading. So can I say both ends are gets blocked, both sides gets blocked, both sides gets blocked there. Now, what is the limitations of the FIFO? Now we need to discuss what is the limitations of the FIFO. One limitation of the FIFO is both ends must and should be opened, then only communication happens. The limitations of the FIFO, both ends must and should be opened, then only the communication happens. Yes or no? Both ends must and should be opened, then only the communication happens. Yes or no? Okay. Second limitation is, try to observe, there is one writing per process. There are multiple reading processes. BE9S7 is asking one question. Let me address that question. As it is half duplex, one can write and another can read. Both can write, read at it. Both cannot write, cannot. In a half duplex communication, both cannot write, cannot read at a time. At a time, both ways cannot be possible. That's why we went for the full duplex communication. Parent, child, parent, child. Got the point? Got the point? Okay. Now observe, there are one writing process, there are multiple reading processes are there. When this process writes the data into the FIFO, no guarantee that who is going to receive it. Observe, one limitation is both ends must and should be opened for transaction. Means reading process as well as the writing process both should be alive, then only communication happens here. Again, we are trying to talk the limitations of the FIFO. We are trying to talk the limitations of the FIFO. The first limitation is writing process and reading process both should be alive at the time of data transfer. It is not such a rule that writing process can write it, reading process can come later, can read it. Again, the limitations here is both should be opened, both processes should be alive. It is not such a rule that a writing process can write now, a reading process can come afterwards, can read it. It is not like that. Again, writing process can write now, reading process can come later, can read it. There is no such method in this. Is that is clear? Second limitation is when writing process is writing the data into the FIFO, no guarantee that suppose here it is read is there, here also read is there, here also read is there. So purely depends upon who is going to get the CPU time slice first, that process will receive. It's not first process. I'll have to observe here, BE8F1 also, try to observe. Here multiple reading processes are waiting for read system call is blocking here. When write will write the data, I can't give the guarantee that which receiver is going to receive it. That purely depends upon who is going to get the CPU time slice first. BE8F1, it is not the meaning that first process. Who came first, that will not. Who is going to who is going to get the CPU time first, that. Because already they are waiting for reading. If one process is writing, if multiple processes are reading, we can't give the guarantee that who is going to receive the data. We can't give the guarantee that who is going to receive the data. Is that point is clear? So there are two limitations. Limitation one, when a process is writing the data into the FIFO, reading process must and should be available. When writing process is writing the data into the FIFO, reading process must and should be available. Second limitation is if multiple processes are reading for the FIFO, which process will get the data depends on the race condition. I hope you might have remembered the term race condition. Race condition means if multiple processes are waiting for the CPU, which process will get the CPU? That is nothing but the race condition. Again, if multiple processes are reading the data from the FIFO and which process will get the data purely depends upon the race condition. In named pipe, there is no such mechanism where transmitter can decide which receiver will get the data. There is no address mechanism. So in this named pipe, there is no concept of the transmitter wants to transfer to data to one particular receiver. There is no such addressing mechanism. If the transmitter wants to transmit the data to one particular receiver, there is no such addressing mechanism in this. So these are the two limitations of this IPC mechanism. These are the two limitations of this IPC mechanism. To overcome this, one more IPC mechanism is introduced. What is that? To overcome this, one more IPC mechanism is introduced. What is that? One more IPC mechanism that is called message queue. To overcome this, one more IPC mechanism that is called message queue. So here in this IPC mechanism, writer have the permission to send a data to only one particular receiver. In this, there is a method, there is a mechanism, there is a process, there is a procedure where writer can write the data into, can send the data into one particular receiver. Writer can send the data into one particular receiver. And also in this IPC mechanism message queue, what we are discussing, a writer can put the data into the message queue, can terminate, a reader can come later, can read it. A reader can come later, can read it. In this IPC mechanism, writer can writer can write the data into the message queue. A reader can read the data at any time they want. Like it is like a post box. Like in your apartment, there are so many flats are there. For every flat, there is a post box is there. Postman will come and see the post box, see the flat number. It will drop that letter into that particular post box so that the flat owner can come anytime, can read, can check that what you call letter, can take it. Is that his point is clear? Is that his point is clear? This is like a post box. Writer can write it. And like till now, whatever we discussed, like what you called FIFO is like a online delivery. Suppose you order something through Amazon. So when the delivery person comes, you should be there. Means the person who is giving and the person who is receiving, both should be alive. Then only the work is done. But whereas normal post box, so the postman will come and drop the message, drop the post into the post box. Later, owner will come and take it. Will you agree? All of you are observing this point. So, the whatever we are going to discuss next IPC mechanism, what is that? Whatever we are going to discuss the next IPC mechanism, that is message queue. It is not a compulsion that transmitter and receiver should be alive. Transmitter can transmit the data. A receiver can come and collect the data later also. Is that point is clear? The functions involved in this IPC mechanism is MSG get. The functions involved in this IPC mechanism is MSG get, MSG send, MSG RCV, MSG CTL. The functions involved in this IPC mechanism is 4 functions: MSG get, MSG send, MSG RCV, MSG CTL. MSG get is useful for create and open the existing message queue. MSG get is useful for create and opening the existing message queue. MSG send is for sending message into message queue. Receive is for receiving message from message queue. MSG CTL is useful for doing some control operations on message queue. Again, MSG get is useful for creating as well as opening the existing message queue. MSG send is useful for sending the message into the message queue. MSG receive is useful for receiving the message from the message queue. MSG CTL is useful for doing some control operations on the message queue. MSG CTL is useful for doing some control operations on the message queue. Is this point is clear? MSG get, MSG send, MSG receive, MSG CTL. So one thing I need to tell you, all of you know that I am using in a Windows Ubuntu app. Will you agree? In a Windows, I am using the Ubuntu app. So here, this message queue service is disabled. In a Windows, I'm using the Ubuntu app. In this, message queue service is disabled. So I'm going to show you this message queue on VirtualBox. Do you know? Do you know VirtualBox? So that we'll discuss in a tomorrow session. Tomorrow, try to plan from 7:30 to 9:30. Is it clear? Tomorrow class plan from 7:30 to 9:30. So this functions MSG get, MSG send, MSG receive, MSG CTL, all these things I'll try to show you on the VirtualBox, so that all the features it is there in that, but in this I cannot show you. It's clear? So if you want, you can go through this MSG get. Tomorrow anyway we'll discuss it. It's clear? So for the time being, I'm going to wind up today's session. For the time being, I'm going to wind up the today's session. In a tomorrow, we'll talk about message queue. It's clear to everyone? Type 1 in the chat box. Clear to everyone? Type 1 in the chat box. Okay. Thank you very much. I'm going to wind up.